So when a body projected upwards, the remaining concepts what we have to see is that important parameters like what is the maximum height traveled, okay, what is the time of ascent, those things we have to study. What is the time of descent and what is the time of flight? Clear? So what are all those things? So you are saying this is a warning. Okay? Let me assume this is point A. Now it has been thrown upwards. So what you are saying, velocity at this point is u and acceleration is equal to minus c. It's clear. So now it reaches some point and again it has to come back. So this particular height from the ground is known as maximum height. The maximum distance it has been travelled from the ground is known as maximum height. Now, the time taken from this ground to this particular point, again it is called as time of ascent. Time of ascent is nothing but time taken by the body to reach maximum height is called as time of ascent, given by symbol T suffix A. So T suffix A is time of ascent. Okay. How did I define this? Time taken by the body to travel from ground to maximum height. So this you consider in upward journey, not in downward journey. It means in your life you are going up, call it as ascent. Okay. So if I consider its downward journey, then it is time of descent. Again from this maximum height point, if I consider in downward direction, then it is time of descent. T suffix D, which is called as time of descent. That is time taken by body during its downward journey from maximum height to ground during its downward journey. This one during its upward journey. So like this you are having two different times. The next time is that time of flight. Time of flight, which can be written as sum of two times, that is time of ascent and time of descent. So the total journey, so from here to here it is ascent, from here to here it is descent. So the combination of these two, sum of these two is called as time of flight. The total time taken by the body which has been projected from the ground to move upwards and then come downwards. So I can say that the total time of the journey, simply total time of journey. So time of flight is defined as total time taken by the body projected in upward direction or simply projected upwards to reach the ground. You could say like this. So in upward motion we have to say ascent, in downward motion we have to say descent. Okay. Some of those two. Now we have to find out or derive the formulas for those things. Ascent, descent and flight as well as maximum height. So how to derive? Very important concept, my dear children. Attend in a very friendly way. How to derive it. Okay. Simple logic. So let us assume the points. First of all, if you assume these points, it will be better. Let this be a point here. Let this be point B. Assume like that. Clear? Now, derive maximum height. So the body is there like this. Now it has been thrown. And then at this point, let me say that it is coming downwards. So this is the case I have to consider. Okay. For maximum height. This is point A, whereas this is point B. Like that you consider. Point A and point B. So here at point A, you have to throw with some velocity. So the velocity at point A is u. At maximum height, if you observe, this is important concept. At maximum height, what is happening? The body has to come down. If it is coming down only, I have to say that is maximum height point. If it is not coming down, then I cannot say maximum height. No, still it is going up. So there is some more maximum height. So what we can say, at some particular point in upward journey, it will return back. So that particular point is so called as the maximum height point. If it does not coming back, still it is going up, then I have to say there is something maximum height. Okay. So the point where it comes back, we call it as a maximum height. And we can also say that at that particular point coming back, no? So it's no velocity. At that point, it is coming back. If velocity is there, it will go up still. Still it will go in upward direction. Since there is no velocity, so simply it is falling freely down. Okay. So at some particular point, we say that the velocity is 0. That is the reason why the body is now, instead of going up, it will come back. The point at which it will return back is nothing but maximum height. And at that particular point, the velocity is equal to 0. Very, very important concept. At that particular point, the velocity is equal to 0. At what point? Maximum height point. Okay. So at this maximum height point, the velocity must be equal to 0. So velocity at point B is equal to 0. Now, how to derive this maximum height formula? I can say maximum height relation. So I told you that the body slowly goes up. At some particular point, it has to come down. It has to fall down. So you have to think why it is coming down. Why? Since it does not have any velocity. It does not have any velocity in it. If there is some velocity, if there is some energy or potential or velocity, it will go up. Why it is not going up? Nothing is there. So at highest point, where we are calling it as highest point, where? The point at which it comes back. From? So look, a body is thrown in upward direction, it reaches up to a certain point and again it will return back. So the point at which it returns, you can say maximum height. Okay. So at this particular point, why it is returning back? Because no velocity. It was very clear that at maximum height or at the highest point, the velocity is equal to 0. Velocity is equal to 0. Remember my dear children. So here B is the highest point at which the velocity is equal to 0. Understood? I think so. Very clear. Now let us find out this relation H max. Okay. So here you know two different velocities. And here H max is nothing but distance between these 2 points. So recollect whatever you have studied initially from me. If two velocities are known and distance is known, in this, if I told you this one, if two velocities are known and time is known, then we have to go for equation, kinematic equation 1, V equal to U plus AT. But here time is not there. Then why should you use equation 1? Isn't it? Then once again, if two velocities are known and distance between them is known, then we have to go for kinematic equation 3. What is that equation 3? V square minus U square is equal to 2AS. V square minus U square is equal to 2AS. Because there V is one velocity, U is other velocity, in 2AS, S is the distance. So when two velocities or distances are given, are known, we have to go for equation number 3. Isn't it? So here at point A, you know the velocities, at point B, you know the velocities, and you know the distance between these 2 points. So why not I go for equation number 3? So, I am writing equation number 3, my dear children. So, V square minus U square is equal to 2AS. This is from point A to B. A to B. Right? So, here A is initial point and B is final. So, what is initial in these two? U stands for initial, okay, and V stands for final. So initial is A. So let me write here A. And final is B. So let me write here B. Okay. So between these two, the distance A to B. So this is the way we could write. Okay, my dear children. So for your understanding purpose, I'll write here initial and this is final. Like this. Clear? Now, at point A, the velocity is taken as u. Whereas at point B, the velocity is taken as 0. Which is equal to, okay, 2 times of. As I told you earlier, if the body is going in upward direction, then acceleration is not equal to plus g. It is equal to minus g. This is what I have discussed earlier. So where acceleration must be equal to minus g and distance from point A to point B is nothing but h max. So I have to replace this distance by h max. This is the way we have to write. Okay. So by solving this, minus u square is equal to minus 2g into h max. These both are cancelled. U square by 2g is equal to h max. U square by 2g is equal to h max. Is it clear? Okay. So very important for relation. Repeating, my dear children, I'll be asking few questions here. So for a body projected upwards, we need a velocity. Otherwise, if I have to project like this, I need some velocity. Otherwise, it cannot go in upward direction, isn't it? So the velocity at initial point, you have to take it as u. First point you have to remember. Now, it reaches up to certain point and then comes back. That point is called as maximum height. That point is called as maximum height or highest point. Second one. The third important thing is that at highest point, the velocity is equal to 0. Is it clear? So by using all this data, we have taken this particular relation, kinematic equation 3, and substitute each and every point, and we got this maximum height as u square by 2z. Very, very important relation, my dear. Very important relation. Okay? I hope you understood this. Now I would like to erase it. Right. So in this application, the next derivation is that we have to derive time of ascent and time of descent. Both the things we have to derive. And then finally time of flight. That's it. Over. So look, my dear, from the real-time data, you understand what is happening in the real life. Real time you understand. The body is thrown from point A to B, right? So that time is called as time of ascent. So you consider only its upward journey. Don't consider complete journey or don't consider downward journey. Okay. So I'm just taking upward. Once again, this is point A from where a body has been thrown. Point A. So let this be point to B. So in its upward journey, the velocity at point A is u. Velocity at point A is u. And acceleration is equal to minus g. Like this. Isn't it? Now I'm interested, and this highest point, the velocity at point B equal to 0. By saying that this is highest point. Yes, we have to say it as highest point. Why not? Because the time taken for the body to reach highest point from the ground, the time taken for a body projected from the ground to reach highest point is known as time of ascent. So how to take highest point? Understood? So from point A to B, you are saying it as highest point, right? From point A to B, the time taken is known as time of ascent, and B itself is known as highest point, and the distance from A to B is known as maximum height. Like this I am saying. So how to find this? Remember, my dear children, previously I told you that if you know two different velocities as well as time, then you have to go for kinematic equation number 1, that is V equal to U plus AT. If this velocity is known, isn't it? Velocity at point A is known, velocity at point B is also known, and you are saying the time taken from this point A to B as time of ascent. So two different velocities and one time is known. If everything is known like this, we have to go for equation number 1, which is nothing but V is equal to U plus A into T. So let us write journey from A to B. So clearly mentioned journey from A to B, my dear. So here A is initial and B is final. So as I told you, U stands for initial journey and V stands for final journey. Is it clear? So initial is point A, so write point A. Final is point B, like this. And time from, you are starting from A and then to B. Initial to final, A to B. So first of all, my dear children, you mention everything, take some time, mention everything properly, real-time understanding. If you observe and solve problems like this, you will get kinematics. Easily you'll understand kinematics. This is not there are two methods. One is formula approach and another one is real-time approach. I am telling you in real-time approach, my dear. So understand each and everything, what is happening from A to B or B to A. You have to mention here, then only you can understand better. Okay. Now, at point A, I was saying the velocity is u. So let me write u at point A. At point B, I was saying the velocity is 0. Whereas acceleration is minus g. So I am writing minus g into time taken from A to B, upward journey. A to B, upward journey is time of ascent. So minus is coming this side. So it is becoming plus g ta equal to u. So time of ascent equal to u by g. Time of ascent equal to u by g. This is the relationship between the time of ascent, velocity and acceleration due to gravity. Now in continuation to this, I will derive time of descent also. So you are saying this is highest point, right? And this is ground. This is point A and whereas this is point B. So now we have to consider downward journey. So if I say this is upward journey, right? Now this will be the downward journey. So here it is time of ascent and here it is downward journey, it is time of descent. Okay. So downward journey means from A to B or B to A. Very clear? Like this it is coming. So it is from B to A. So there you mention that journey is from B to A. So time is from B to A. Upward journey going from A to B. So this one already solved from A to B. Now we are trying to solve this from B to A. Okay. So how did I define time of descent? The time taken for the body to move from maximum height to the ground. So here it started. Journey here it has been started. So this is start or you have to say initial. So where it start coming like this means what I told you at this height, maximum height point, I have already declared that the velocity at the maximum height point is equal to 0. The velocity at maximum height point is equal to 0. This is what I told you earlier. Now the velocity at this particular point is u. Okay. Now let us solve this. You need a time. Okay. So two different velocities and time. So again, I'll go for the same equation. No change, nothing. But here it is coming down. So whenever it is coming down, I have to say that acceleration is plus g. It is not minus g. This is what the difference in these two derivations. Previously here I have taken acceleration equal to minus g. But now I am not taking minus g. Since it is coming downwards, I have to consider from this time, not from this time. Okay. I should not consider this. So this will be my initial one. So when I am considering from here, initial velocity is here only. That is equal to 0. And since it is coming down, the acceleration is plus g. That is what I am declaring because time of descent is nothing but time from maximum height or highest point to the ground. Time taken for the body to reach or to move from highest point to ground. So this is ground, right? So downward journey. So I have to take acceleration as plus g. Now let me take the equation. Having two different velocities, I know the two different velocities as well as I know the time. So equation as I told you before, the same thing I'll take. V equal to u plus at, but with minor changes. What are the minor changes? Instead of A to B, B to A, B to A. So here Now this B is initial and A is final. So as per our logic, this is initial. So initial is B and V is final. Okay, so final is A. Like this. So this is final point and this is initial point as per our logic. Our journey is from B to A. So I have to say the time is from B to A and acceleration is from B to A. Previously, or from journey from A to B. So we have taken our acceleration from A to B. A to B means upward. So it is minus G. Now, B to A, downward journey. So it is plus G. Okay. So let me write here. This is plus G. Mention time from B to A as time of descent. Velocity at this point is 0. And velocity at point A is U. So now you think that why sorry writing here UA and VB like that, no? But here in opposite way. Look my dear children, U and V. Don't get confused. Nothing is there in that. You better read like this. VB is not final. Okay. Velocity at point B is 0. So here UB, velocity at point B is 0. UA, velocity at point A. So read it as velocity at point A. Don't say that it is initial. So velocity at point A is U. So velocity at point A is U. So like that you have to understand. Not by saying U means initial, V final, not like that. But if a suffix is given, it was very clearly mentioned that at that particular point, whether it is A or B, that it is defined as at point B, the velocity is 0, defined. At point A, the velocity is U. Because with what velocity you are throwing, with the same velocity it will reach the ground. No doubt in that. The thing is that here it is going upward, right? And when in return journey it is coming downwards. That's all. So that is the only thing. Now here you get U is equal to G into TD. So U by G is equal to T suffix D. So like this I will get time of descent. Okay. So from the basics concepts only I have defined these two. So time of descent is equal to U by G and time of ascent is also equal to U by G. From these two, what could we say is that time of ascent is always equal to time of descent. Time of ascent is equal to time of descent every time. So therefore, from these two, time of ascent equal to time of descent. So the final thing to complete this concept is time of flight. So students, here itself I want to discuss that. How do you define time of ascent? Combination of time of flight. How do I define that? Time of flight is nothing but in two ways I told you. One is sum of ascent plus descent, numerically. Yes or no? And other one is total time taken during its journey. So let us see, its journey started at point A to B, that is ascent, and then it has got to be stopped. Again from B to A, he got it. So A to B journey and again returning back from B to A. So two different journeys. If I am saying A to B, it is ascent and B to A, it is descent. So I have to mix up everything. Then only I will get the total journey. So here the total journey is nothing but time of flight. Okay. So time of flight. Where could I write it? Okay, my dear. I would like to erase it and I would write it. So time of flight, which was represented by capital T, which is equal to total time of journey, that is time of ascent from A to B plus time of descent from B to A, like this I can say. Or if you want, you can write like this, time taken from A to B plus B to A, like this. Okay. So now time of ascent is U by G. So U by G plus descent is also U by G. So answer is 2U by G. So finally, time of flight is given by the formula 2U by G. Like this I could tell you. Okay, my dear children. I hope it is very clear. Okay. So once again you go back and look at this video, you will understand better. Thank you.